Hi, welcome to my video on find the reciprocal trig ratios of theta if a point lies on the terminal arm of theta. Theta is the angle of rotation. Reciprocal trig ratios. Let's recall that SOHCAHTOA, S-O-H-C-A-H-T-O-A, SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, dealing with SOHCAHTOA. And this was learned in the right triangle trig unit. And related to that, also is the reciprocal ratios. Sine begins with S, so cosecant, CSC, is hypotenuse over opposite. And cos, COS, begins with C, so it's reciprocal is secant. SEC is hypotenuse over adjacent. And the reciprocal of tan is cot, COT, is adjacent over opposite. Notice they're flipped upside down. So let's plot a point. Let's plot a point P, which has coordinates of x, y on the xy plane. And let's draw a terminal arm that's going to go out through that point P. And let's select this as the radius, and let's draw a circle. I'm going to do it without the compass, see how I can do. And there's a circle that has this radius from here to here. So that means that that's the same distance right there. So this point is r, 0. And as a result, we drop a perpendicular to the x-axis. We never drop a perpendicular to the y. Always, from this point, we always drop it to the x-axis. As a result, the coordinates of this point are x, whatever this number is, then that goes right there. And whatever the y is, that number goes there, because this is the y value going up, this is the x going over, perpendicular. And as a result, we have sine is of, and theta is this rotation right here. Theta is the rotation on this point R0. This is the rotation on the circle, and this rotation here is the arc. So therefore the central angle has the same measure, so this is theta in here, and this is your, what we call the reference angle. This is the reference angle in terms of the triangle, because the reference angle is between the terminal arm and the x-axis in relation to the triangle drawn in the quadrant 1. We could also draw them in quadrant 2, quadrant 3, and quadrant 4. So sine theta is in relation to, sine is opposite over hypotenuse. So that's sine is the y over the r. And cos, or cosine, of theta is the adjacent over the hypotenuse. So that's adjacent, is the x over the r. And tan theta, tan is opposite over adjacent, so that's the y over the x. So you have to memorize these, learn them, not hard. And so the reciprocal of sine is cosecant CSC. So the reciprocal is r over y. Cos, reciprocal is secant, and it's the r over the x. And the reciprocal of tan is cot, and the reciprocal of y over x is x over y. So I learned this, I keep this in relation to the circle. I have this memorized. So let's use an example. Find the reciprocal trig ratios of cos if the point is -815 lies on the terminal arm of theta. Okay, well, let's plot let's draw the XY axis. And not going to be accurate, don't have to be accurate, just going to draw the illustration. The point is -8, so let's go over here, pretend -8 units to right here. And let's go, y is 15, so let's go up 15 units, and let's pretend 15 is up right here. So the point, x is -8, y is 15, so that point lies right there. So that's -8, 15. So what we do is we draw a terminal arm from the origin 0, 0 out to that point. And as a result, we have a circle that goes around like that. And this is the radius of the circle. We drop a perpendicular to the x-axis, never to the y, always to the x. And x is -8 right there. Y is 15 right there. And we have to find what r is. And just to recall, c squared equals a squared plus b squared is the Pythagorean property. So because we have a circle and we have the hypotenuse opposite the right angle is r, a and b are the values of x and y. That's x and that's y, as in right here. So we have r squared is x squared plus y squared. And we want to find the radius. So x is -8 squared. Y is 15. We're going to square it. And so -8 is 64. 15 squared is 225. So r squared is 289. And that means we do the square root of each side. Plus minus the square root of 287. So r, the square root of r squared is r, plus minus, and the square root of 289 is 17. Check your calculator. 17. Now we have to do cosecant. So we can do the sine and get the reciprocal, or we can do it right away. We can get what sine is, or we can get cosecant right away. Cosecant is the reciprocal of sine, so it's the r over the y. And secant, theta, is the r over the x. And cot, theta, is x over y. Again, you learn these, you write them down, you keep them in track, and you keep this in your head or on a sheet of paper when you start your trig. Always keep this in mind. As a matter of fact, what you do, you draw this diagram. Keep it in mind. So, the cosecant is the radius, which is 17, and the radius is never negative. So r is equal to 17. So 17 over the y value, which is 15. And secant is the radius, which is 17, over the x value, which is -8. But I never put a negative in the denominator. So, oops, sorry about that. That's -17. I'm going to change the fraction then. That's a -17. The negative goes on the top instead of on the bottom. So 17 over -8 becomes -17 over 8. And the x is -8, and the y is 15. So that's working out the reciprocal trig ratios. Again, you can do the cos, sine, and tan, and just flip them around and do it that way. Or you can do what I did. Cosecant is the radius over the y, secant is the radius over the x, and cot is x over y. Memorize it, learn it, be able to write it down very fast. And we have another example to do. So this time what you can do is pause your video and work this question out. Here we go. Find the reciprocal ratios of beta if the terminal arm of beta passes through the point -2, -4. So this, I always draw a diagram. There it is. And this is the x, and that's the y. Remember, x is positive here. y is positive here, x is negative on this side, and y is negative down here. So we have the point x is negative 2, so let's say that's a negative 2, and y is negative 4. So let's say that's negative 4. Don't have to go, you don't have to mark them off like that. So x is negative 2, y is negative 4. That's that point right there. Negative 2, negative 4. We draw a terminal arm going out to that point. And we have a circle. So we draw a circle. There's the radius of the circle. So this is, we draw the circle. Again, you don't have to be exact. I'm just drawing an approximation. And we drop a perpendicular to the x-axis, always to the x. So the x value is negative 2, which is right here, and the y is here 4. So x is this value, negative 2. Y is this value, the vertical, 4. And we have to work out the Pythagorean, so it's x squared plus y squared equals r squared. Or you can reverse it, r squared is x, your choice, either one will do. And you can do this one to this one. So x is negative 2, y is negative 4, equals r squared. Negative 2 squared is 4, negative 4 squared is 16. Remember, negative times a negative is positive. That gives us 20, equals r squared. We do the square root of each side. Oops, that's an F. Make sure now that's an R. We don't do much talking. Square root of R squared is plus minus the square root of 20. Square root of R squared is R. And 20 is 4 times 5. So the square root of 4 is 2. So it's a 2 root 5. So that's plus or minus 2 root 5, because when you simplify radical, you look for a factor which is the perfect square, which happens to be 2. So the square root of 4 is 2, and we leave the root 5 there. And this time the radius is positive, so it's 2 root 5. So we put the 2 root 5, that's the radius right here, from here to here is the radius, so that's 2 root 5. And we want the cosecant, we want the secant, and it's all beta. So let's illustrate. Beta is this rotation from the initial arm. This arm rotated all the way around and stopped here. So here we go. This is beta rotation. This is the beta rotation. Notice it's a quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're in quadrant 3, but we're beta. This is beta. And the cot of beta, and beta B. So beta is cosecant, begins with C, so that's an S, so that's sine, so it's a reciprocal of sine. So it's the radius over the y, and secant begins with S, so it's the cos. Cos is the x over the r, so secant is the r over x, and the reciprocal of tan is cot, so tan is the y over the x, so cot is the x over the y. And in relation to this diagram, we have the hypotenuse is 2 root 5 over y, which is 4, so that reduces to, the y is, I don't like to make a mistake, the y is negative here. So that's that over negative 4. So that's a negative, that's a positive, and that's a negative. So it's a negative. 2 cancels once, 2 and 4 goes 2. So it's a negative root 5 over 2. and the radius is 2 root 5, and the x is -2, and the x's cancel out, and a positive divided by negative is a negative root 5. And the x over the y is -2 over -4, which is 2 into 2 goes once, 2 into 4 goes 2, positive. And notice tan in this quadrant is the x over the y, or cot is the x over y, tan is y over x. So tan or cot in this quadrant is always positive because the two values of x and y are equal, same sign, so it's going to be positive. Tan is also positive in quadrant 1 because the x and y are both positive. When you divide x by y or y by x, the same value, you get a positive number. So that brings us to the end of finding the reciprocal ratios of a trig ratio. And again, just to review, sine of any angle, sine is the opposite over hypotenuse, which is the y over the r. Cos of an angle is the adjacent over the hypotenuse, which is x over r. And tan of theta is opposite over adjacent, which is the y over x. And if you just illustrate that here, and you quickly draw a diagram like that, you put a point in, there's the point xy, and you drop your perpendicular. So this is the x, and that's the y, and that's the radius. And there's your reference angle right in this corner. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So when you do cosecant, you go hypotenuse over opposite, which is the r over the y. Cos, secant is the reciprocal, so it's the r over the x. Reciprocal of tan is cot, so it's the x over the y. And learn this, be able to draw this diagram very quickly. And there's the rotation from here to here. That's the rotation that's on the circle called theta. So this, and we always work it out in relation to the reference angle. We use the reference angle to work out the values of the rotation. And that brings us to the end of finding reciprocal ratios on a point on a circle. And if you like my video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.